Welcome to Ask and Learn.
Problem 23.46. We have a uniformly negatively charged sphere with a tiny little empty tunnel through it going from one end to the other. We can place a proton anywhere we like, outside of the sphere or in the tunnel. We'll call F sub r the force on the proton at the surface of the sphere. And then as a multiple of the radius of the ball r, we want to find the distance from the surface of the sphere. So this is actually going to be r minus r, such that we get 1/2 of the force at the surface. A, we want to do it outside, and B, inside. So we, outside of the sphere, we know that F of r is going to be the charge on a proton times the charge on the sphere divided by 4 pi epsilon naught r squared. And we want this to be equal to 1/2 F sub r, which is EQ over 4 pi epsilon naught big R squared. So now all this stuff except for the r's and the 1/2 go away, they cancel. And so the radial position from the center of the sphere is going to be the square root of 2 times r. Recall, we're wanting the radial position minus the radius because we, outside at least, because we want the distance from the surface. And so that's going to be the square root of 2r minus r, or r times the square root of 2 minus 1. The square root of 2 is approximately 1.414. 1 is exactly equal to 1. So this will be 0.414 times big R. Now if we put our proton in the tunnel, we just sort of do the same thing here, except the electric field in the tunnel, is going to be IS. It'll look similar, 4 pi epsilon naught r squared times r. Should be an r cubed, I think. And then F sub big R still has the same expression. And as we've seen before, the electric field inside a sphere of uniform charge density is a linear function until it reaches big R, and then it will reduce to this, and then go down as 1 over r squared afterwards because it looks like a point charge. And so this tells us that the distance from the center of the sphere is 1/2 times the radius. And because this is directly halfway between the origin and the surface of the sphere, this is also the distance from the surface, so we can save ourselves writing out anything else with that. And there we have it.